Hello everyone! In this video, I will be going over how I built Connect 4 in Minecraft using Redstone. I recently finished watching Mattbatwings' Logical Redstone Reloaded series, and for those of you that have seen it, you may remember that in the last episode, he builds Connect 4, so I decided I'd have my own try at creating Connect 4, and as an extra challenge, I would try making it with wind detection. This ended up being a really fun project to work on, so allow me to show you how I did it. The first thing I did was figure out how I would store the state of each cell. In Connect 4, each cell can either be empty, or it can contain a red chip or a yellow chip. I created 2 bits of data to store the state of each cell. If the bottom bit is on, then it will display a red chip. If the top bit is on, then it will display a yellow chip. And if neither bit is on, then the cell will be empty. Next, I added a display. Like Mattbatwings, I also decided to display the chips as O's and pluses. I then stacked this up 6 times to create a full column of the board. Next, I added this circuit. This circuit will allow you to toggle between the 2 different chips, and hitting this button will unlock these comparators, which will write that data to each cell. But we only want to write to the lowest empty cell. What I needed to do next was to create a circuit that would lock every cell except for the lowest empty cell. But how can we detect the lowest empty cell using Redstone? Well, there are a few ways of doing this, but here is the method I went with. I did this by implementing 2 rules. First, if a cell is set, then it will lock itself. This makes sense because we don't want to write to a cell that already has a chip in it. Second, every empty cell will lock the cell directly above it. After doing this, the lowest empty cell is the only unlocked cell. This way, if we try to write to every cell, the lowest empty cell is the only cell that will update. And here is the redstone circuit that implements these 2 rules. If we try to write to each cell, it will set only the bottom cell. And if we try to write again, it will set the next lowest cell. After completing this circuit, I copied the column over 7 times to complete the 6x7 board. Next, I added a button beneath each column. Hitting this button will place a chip into that column, and it will toggle the state of the next chip. With that, the base game was almost complete. There were just a couple things I needed to add. I added a reset button that will deactivate every single bit, effectively clearing the board. Another thing I decided to add was a safe hold in case a player tried to drop a chip into an already full column. Right now, if X, for example, tried dropping a chip into this column, it would toggle the state of the next chip, meaning the next move would be an O, even though X never dropped a chip. So, to prevent this, I added this green circuit. All this does is that if the topmost cell becomes set, then it will lock this comparator, which will block any inputs from that button. After doing this, I had a functioning game of Connect 4. Now it's time for the hard part, wind detection. The reason this is so difficult is because in order to fully implement wind detection, we need to check for every possible wind state that can occur on the 6x7 board. There are 24 ways a player can win with a horizontal 4 in a row, 21 ways a player can win with a vertical 4 in a row, and there are 24 ways a player can win with a diagonal 4 in a row. This adds up to 69 win states for each player, and 138 win states in total. This may not be a lot for a computer to handle, but for Redstone it's a different story. The most intuitive way to check for all these win states is to use a decoder, but this would take up a lot of space since we'd need a redstone line to decode for every single win state. I knew there had to be a better way to implement wind detection. After thinking about it for a while, I eventually came up with a solution. That solution was to use signal strength. Here's how it would work. Here, we have a single row of the board. In front of this row, I added a one-way redstone line. The line is one way because a redstone signal can only travel up glass blocks, but it can't travel down. I'm also powering the redstone line in front of each cell. Now, say we wanted to test if O has a Connect 4. To do this, I'm going to unpower the redstone line for every O. Now notice how the entire redstone line still remains powered, but it gets weaker in front of the O's. If we add one more O to create a Connect 4, then this part of the redstone line will unpower. So we know that if any part of the redstone line is unpowered, then O must have a 4 in a row. Using this concept, I created this circuit. As you can see, there are two one-directional redstone lines, one for each player. If the circuit detects that a player has a 4 in a row, then it will send an output along one of these redstone lines. Thanks to this technique, I was able to make the horizontal win detection half as small as if I had instead used a decoder. Next, I created this circuit to test for vertical 4 in a rows. This works the same way as the horizontal circuit, except now the redstone lines are placed vertically along these glass towers instead of horizontally. Lastly, I had to check for diagonal 4 in a rows. This was a bit tricky since I had to weave the redstone lines through the wires, but I eventually got it working. Even though this method of win detection ended up being a lot smaller than decoding for every win state, it still ended up taking the majority of the contraption's size. Lastly, I created a display that will show when a player has won. And with that, the contraption was complete. This was a very fun project to work on, and I am very happy with the result. If you would like to learn how to build contraptions like this yourself, check out Mattbatwings' Logical Redstone Reloaded series. He explains redstone in a way that's both engaging and easy to understand. The link will be in the description. There is also a world download link if you would like to try out the contraption yourself. If you enjoyed this video, please consider liking and subscribing. I am a small channel, and your likes, comments, and subscriptions help this channel grow. Thank you for watching, and I'll see you next time.